Good morning, everybody. My name is Vincenzo Corrado. I'm professor at Politecnico Torino, and I will chair this webinar together with my colleague Ilaria Ballarini. I will give her the floor during the webinar, and then she will chair up to the closure of the webinar.
Good morning.
Good morning. First of all, this webinar has been organized within the TIMEPAC Academy. The TIMEPAC Academy has been established within the H2020 TIMEPAC project, and it is a dedicated space aimed at offering comprehensive education, training, and resources, especially tailored for professionals engaged in the building energy sector, with a specific emphasis on building assessment, certification, and the energy sector. This is the fifth webinar in a series of 6, and the title, you see it, is Exploitation of EPC Energy Performance Certificates for Local, Regional, and National Energy Planning. The aim of this webinar is to explore the potential of the use of the energy performance certification databases to develop an archetype-based urban building energy model as devised in the TIMEPAC project. And the webinar offers a comprehensive training in the statistical analysis of the EPC database with the goal of leveraging it for benchmarking initiatives. You can anyhow read more information on the TIMEPAC Academy website. We have speakers from 4 countries, Slovenia, even if I don't see him in the list, then Austria, Spain, and Italy. Politecnico is the TIMEPAC participant that organized this webinar. We have a tight schedule, so each speaker will have 15 minutes, including possible questions. But please, any question should be written in the chat. Then at the end of each speech, if there is some time, I will ask the speaker to answer. Otherwise, it will be possible to answer in the chat or possibly at the end of the webinar according to the time schedule. But of course, Ilaria will manage this closing part. Okay, if there are no questions, I think we can start with the first speaker that I don't see. So if is in the webinar, please take the role of a presenter. Otherwise, I will switch to the second speaker, which is Alvaro Sicilia from La Salle URL. Alvaro is a researcher of the Arc Engineering and Architecture La Salle Research Group. He holds a PhD in computer science from Ramon Llull University, and is a professor of the databases course at La Salle Engineering School. He currently coordinates the National Research Project RETABIT, and also actively participates in the TIMEPAC project and in the Accord project. The title of presentation is Identifications and Collection of Relevant Data from Energy Performance Certificate Databases to Map the Energy Status of Building Stock. Alvaro, you have the floor.
Okay, thank you, Vincenzo, and good morning. The presentation is this presentation is about how to work with EPC databases to map the energy status of the building stock. Today, I'm going to introduce the EPC databases. These databases, as all of you should know, or probably you will know, they store energy performance certificates issued by the certifiers. And these databases play or will play a key role within the EPBD recast that has been approved a couple of days ago. This recast in the Article 19 says several things about databases. You have them written in the screen, but I'm not going to read them. The main things about the recast and the EPBD databases that the EPBD calls for the interconnection of databases, EPC databases, national cadastre, the digital building logbook, the European Building Stock Observatory, and also calls for putting together data coming from EPCs, from inspections, from renovation passport, smart readiness indicator, consumption data. So the idea is to make interoperable all the public databases and make them accessible to the citizens, the public authorities, and the third parties to carry out analysis, to create their own businesses. So the idea is to share all of this data in an interoperable way. In this session, I will explain you how to use a EPC database to map the energy status of the building stock. Usually, this process is divided into 3 steps. First, we need to understand the data that is stored in the database, so the data items. Then, once you have understand this data, we need to collect the data and to clean the data, because this data may have some data issues, some data that is incoherent or some errors. And then the last step is to aggregate the data at different scales or at different dimensions and visualize, provide some visualizations to the decision makers. With regard to the first step, which is understanding EPC data items, here we need to see, so the data that is stored in the EPC databases are grouped in several categories. General information about the building information at the current state, technical building systems at the current state of the building, the EPC results, which are the indicators that a certifier generates for an EPC, and then the building information at the improved state. So to map the energy status of the building stock, we need the data from those categories that are highlighted in green. So let's look at the details. In order to understand how the different country pilots of the TIMEPAC project store the data, the EPC data in the databases, we conducted some analysis in the first year of the project. We carry out several reports about how the databases are managed, how the data is stored. And one of these reports is the EPC data analysis that was led by Politécnico de Torín. And for each data item, the energy agencies from these 6 countries that we have in the TIMEPAC project, they indicate if they are storing that item or not in their databases. For example, you can see the degree days that is only stored in 4 databases out of 6. And, for example, the climatic region that is stored in all databases. So these figures are important to understand if a data item can be used for our analysis or not, because maybe you can use it here in Italy or in Spain, but not in other countries. So for mapping the energy status of the building stock, we can use the climatic region, because this item includes the climate conditions, which has a high impact on the energy performance. Also, another data item that is important to carry out this analysis of the building stock is the building typology, which characterizes the building according to the several construction periods and uses. However, as we can see in the figure, not all of the databases includes this data, the building typology, only 4 of them, yeah? So in case we don't have this data, we can use the year of construction of the building, which can be related to building codes or construction practices. Another items that are interesting are the geographic location and building address, because these items will help us to, for example, to aggregate the data at different scales at one municipality or one neighborhood, because we have the location. Yeah, so this is also important. Then, with regard to the building information at the current state, the most useful attribute or item is the thermally conditioned floor area, because with this attribute we can carry out this analysis across different building sizes. With regard to the EPC results, which contains all the main indicators calculated by the EPC, the most important ones are the energy efficiency rating class, the CO2 emissions, the energy performance indicators, so the non-renewable energy performance indicators, and also the energy need for space cooling and heating. And it's, as you can see in the screen, it's important because all databases that we analyzed contains these indicators, so we can use them. Okay, so now that we understand the data that we have in our databases, the second step is to collect this data and then to clean it. And it's important to clean it. And I wanted to stress that because if we don't clean it, the analysis that we will carry out from this data will be flawed. So we cannot trust them. Yeah. So it's important to find mistakes in the data and to fix them. In this presentation, I will show you a very basic way to do it, which is just filtering, but advanced techniques will be explained in the next session. In the next presenter will show these advanced techniques. So before moving to an example, let's talk about the databases. Yeah? A certifier issues an EPC. This EPC is stored in the EPC database, but usually we don't have access to this database. It's not possible. However, we may have access to the open data portal attached to this database. So from now on, I will use the data portal from Catalonia to illustrate the examples. So the first example is that we want to carry out an analysis to understand the residential building stock of Sant Cugat del Vallès. The first step is to select the EPCs that are only in that particular municipality, and then to say, to specify that the building use should be residential, single family house, a building block, or apartment in a building block. Once we have it, this small data set, then we need to identify issues, data issues, and we need to fix them. So the interface on the screen is the Open Data Portal of Catalonia, which enables users to make basic analysis. So this table is the certificates that we have. In this data portal, we have 1,400,000 certificates. And as you can see in the screen, we already filtered by municipality, which is the first filter. And then also we filter by residential uses, which are those that here are selected. And now we have only 13,000 EPCs in Sant Cugat. So this is the first step. Then we can analyze the data, the table, and we see that are some rows that we don't have data for some indicators. So we need to remove these rows, these EPCs from our analysis. So for doing that, it's very easy. We will set up a new filter and we will say that the non-renewable primary energy will be greater than 0 or different than empty value. And then we remove those values. Then another analysis that we can do is ordering the columns. We order one of these indicators and we see here in red that we have a very high values for energy indicator, around 18,000 kilowatts hour per square meter per year. It doesn't make sense. Yeah, so we need to filter them. So to filter them, we need a threshold. So we need a threshold to say that this indicator is out of bounds. In this example, I put a 700 kilowatt hour per square meter, but this value should be calculated. And in TIMEPAC project, there are some guidelines to calculate these confidence intervals. And yeah, so now the dataset is clean. We can download this dataset and carry out our analysis. The third step is the data aggregation and visualization, and the data can be aggregated different scales. For example, a geographical scale, neighborhood, municipality, province, and so on. Yeah, and also the data can be aggregated by building type, single-family house, multi-family house, or time periods, buildings from the 60s, from the 80s, and so on. Yeah, so and you will do these aggregations according to the needs of your analysis. So after the aggregation, we can visualize the data in different ways. For example, with a map, with a bar graph, a line graph, or any visualization that may help decision makers. Because at the end, this visualization is to understand a problem and to provide a solution. In the Open Data Portal of Catalonia, we can create these visualizations as the one that you see in the screen. This is a scatter point visualization that I set up two axes. The vertical axis is CO2 emissions, and the horizontal axis is non-renewable primary energy. And usually those indicators are correlated, usually, yeah? As you can see, these lines, these points, each point is an EPC, by the way, so they are correlated. But there are some EPCs that has strange or unusual points because they have a low primary energy, so less than 100 kilowatts, but a very high value of CO2 emissions. So through these visualizations, we can also find issues in our data and we can clean it, yeah, providing more filters. In this visualization is another one. We aggregate the data by building use. So we have different energy indicators for single family house and multifamily house. And we are visualizing non-renewable primary energy and heating demand and cooling demand. So these visualizations can help us to understand how our buildings of our municipality behave. Another interesting visualization is to use a map, so to map the buildings in the territory. So for doing that, we need the building location. And in this example is a heat map of the buildings that belongs to Sant Cugat del Vallès, but only those that has the worst energy class, which is the G class. And for example, in this case, we can see that these red areas concentrate a lot of buildings that has a worst class. So maybe in those neighborhoods, we can do some renovation actions. Also, we can aggregate the EPC data at municipal level. Here we can see Catalonia with a lot of municipalities, and the color is related to the average of energy, non-renewable energy performance of the EPCs. And the northern west of the municipalities are consuming much more than the coast municipalities. This could be the first analysis. Also, this data can be, again, aggregated at county level, and the conclusions will be the same. However, if we count the number of certificates, we will see that we have much more certificates in the coast than in the mountains, than in the northwest area. So at the end, you need to, in order to carry out the analysis or do the decision making, you need to understand all the variables that you have in the database. Okay, just for finalizing this session, collecting data from an EPC can be a tedious task because you need to understand the data, you need to clean it, and you have to clean it. This is important. You cannot overpass this step because if you do it, then the analysis will be wrong. These visualization techniques that I show you, this is a sneak peek about visualization, can help you to find flaws in your data sets. So it's important to use them. And another important thing is that EPC databases can help you to understand the energy status of the building stock, but only of those buildings that has been certified, which are not all the buildings that we have in the building stock. So if you want to do a full mapping on the energy status, then you will require advanced techniques. These advanced techniques are based on building archetypes, and in the next sessions, my colleagues will introduce them. Thank you.
Thank you, Alvaro. I don't see any question in the chat. So I remind everybody, if you want to make any question, please write in the chat, and you will get at least a written answer. I see that our first speaker has joined the webinar, so I go back to his profile, and I introduce Mr. Eric Potočar. He works at the Energy Directorate at the Ministry of the Environment, Climate and Energy of Slovenia. He holds a Bachelor of Science degree in Mechanical Engineering and has also earned a Master's degree from the Faculty of Mechanical Engineering, specializing in wind turbines. And in his current role, Eric is responsible for the implementations of renewable energy sources, Energy Efficiency Directive, and Energy Performance of Buildings Directive, the EPBD measures, in the Ministry of that I mentioned before. So, Eric, you have the floor. I guess you have to share your screen because we don't have your presentation in the shared file. Eric, can you? I cannot hear you, even if your microphone seems to be activated.
Do you hear me?
Yeah, now we hear you, and we also see your presentation. So you. Maybe,
you hear me? It's okay.
Yeah, maybe you can put your presentation in the presentation mode. Now? Yeah, it's okay. It's okay.
Okay. Thank you, and I would like to apologize because of this change. I have a bad connections now. I have a little better connection, so I think everything could be okay. I don't have the camera because of that, so for that I would like to apologize. But you saw my picture for beginning. My purpose of this presentation today is how to see what's the new EPBD, what's coming, what's the new challenges, and in which direction we are going. So the EPBD.
Please, Eric, could you set your slides in presentation mode, because now we see all the notes and very small.
It's not yet.
No.
Now you have?
Not on my screen.
Because I have full screen. I will try again. It's now, you now see the whole screen?
No, I don't see. I don't know about the other participants, but it seems that
we cannot see it. We see just the PowerPoint, not the full screen.
Eric, maybe you share a screen. Maybe you share window at present. So you shouldn't share window. You have to share screen.
Just a moment. I will try again. Okay.
Okay.
Let's go again. Sorry. Just a moment. Yeah. Do you see something or no?
No.
You need to move to a PowerPoint now, yeah?
Just a moment. I will try to open it. The other PowerPoint, maybe.
If you move to your PowerPoint now, it should work, I think.
Yeah, I'm not doing this first time. Just a moment. Let's try again. Because we will solve that. Now it's possible to see.
We see it again, but now it is not yet in presentation mode. So you have to.
Yeah, and we have something with the presentation mode problem. Yeah. I don't know where is the problem, because I'm on the laptop. I'm not on the other computer.
Okay, if you don't solve, you go ahead with this mode.
Can you
Maybe-
present, and I will just say, you have my presentation. Can you put it on, and I will say next slide. Maybe this is the best solution.
No, I think you can proceed. Maybe you can reduce the dimension of the nodes and increase the size of the slide. Yeah. Okay. Now it works. Yeah. Okay.
Is this
You can
okay?
go. Yeah. It's okay. Thank you. Go ahead.
Okay. 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 From my side, I will tell you what's the latest with the EPBD, what's happening, and in which direction we are going. Of course, EPBD directive, one of the directive part of the climate goals, it's important as renewables at energy efficiency, and for some measures, it's really concrete. So with this new directive, we will really get some new things. So the EPBD, the purpose of EPBD is how to decarbonize the building sector, of course. So that we need to increase the annual renovation rate, which is essential. If we would like to decarbonize the building stock by 2050, we need to at least double or triple some sectors of the buildings of renovation of such a buildings. If we look today, for example, you can see that approximately 1% and something more yearly buildings undergo for renovation. Most of the buildings, if we look today, minimum energy requirements, more than 75% of the building stock is not energy efficient. That means that we really have a lot of potential for that renovation. And most of the buildings, especially in the EU, they are still in the use, and there will be in the use in 2050. That means that the revision of the energy performance of the building is really opportunity to go a little bit further with this decarbonization, and because of that, we're really getting some new measures and really interesting things. So we can put this revision in 4 different areas: renovation area, financial part, decarbonization part, and modernization, or with other word, system integration. That means in one way, we getting new minimum energy efficiency standard for solar standard. We can say we have some new things with certificates. On the financial part, we are getting new instruments, how to go a little further with investment in this building directive. Then we are talking about decarbonization. That one of interesting thing is maybe we are talking about until now we were always talking about nearly zero energy buildings. From now we will talking about non-emission, zero emission buildings. On the other hand, directive is talking about phase out of the fossil fuel incentives and where to go in that way in direction. So there's really a lot of topic in which direction to go with this new directive. So for beginning, maybe I can just add that if I can just mention, we started to talk about the smart cities. Really, smart cities is important, and this minimum energy efficiency standard, if we would like to have smart city, at first we need to do it on the energy efficiency level, and this energy efficiency standard is really important. With this new directive proposal, okay, it's not finally published in the official EU journal. With this energy efficiency standard, we are talking that there is a little change that we will need, all the member states will need to do a little more with the worst buildings. That means for non-residential buildings, that means that until 2030, 16% of the worst non-residential buildings will need to go over that threshold. That means from beginning, every member state will need to define what means, what are buildings and the building stock for 2020, for example, and then check which present this 16%, and then put these houses over that minimum requirement. then we have by the year 2033, 26% of these worst non-residential buildings will need to be over this threshold. That means that with this minimum energy efficiency standards, we will need to do a little more with worst buildings, and this can really help us to go a little further with this renovation. For residential buildings, it will be similar, but it will be on primary energy use, and we also will have the goals for the 2030 and 2035. If we look a little closer, I already mentioned zero emission buildings. With this new directive, we are getting definition of zero emission buildings and what these buildings means. These buildings means really building, which is at first stage, of course, energy efficiency first principle. The house needs to be very efficient. On the second house, almost zero or non-fossil fuel carbon emissions can be produced on the house on the site. And of course, the energy which used can be at least renewable sources. That means the zero emission buildings in the next years with new directive will become standard. And this new standard will be at first obligatory for new public buildings, later on from 2030 for all new buildings. That means that in the next years, probably we will talk a little much more about zero emission buildings. With that also it's coming life cycle global warming potential as one of important things. That this is indicator and with this indicator we can calculate and quantify the global warming potential of the building over entire life cycle. That means for the material which is produced, then this material when it's transported to the location, and of course then build it into the house. That means that all these emissions which are of all that material can be quantified and can be put and presented to all the stakeholders, the owners, and so on. That means that in the future we will talk about this, and it will be obligatory for different buildings from 2028 for all new buildings or the bigger buildings over 1,000 square meters, and later on from 2030 for all new buildings. I also mentioned solar standard. Solar energy, it will become obligatory in buildings. Of course, there will be at final discussion of directive in which direction to go. There was the conclusion, and here we have where we need to go. That means from the first side, it will be obligatory in new buildings, new public, of course, and non-residential buildings from 2026. Bigger buildings than 250 square meters. Later on, we will, for non-residential existing buildings, it will be important that they need to put solar energy in the buildings, and which buildings they go undergoing, the buildings which are going under from the major renovation. That means that from the year to year, there will be also come to the existing building and especially with the public existing buildings. And you can see with the numbers and the square meters, how from the year to year it will be growing. Of course, there is also this obligatory also for the covered parking lots. And it's also important to mention, of course, it's not, especially when we are talking about existing buildings, it's not possible to put it everywhere. There will be some possible exceptions, and the member states can define where are some technical, economic possibilities where it's not possible to put it on. But basically, it will become very important. Renovation passport, also one of very important measures, which will really help people how to understand how to decarbonize your own building. That means that you will need to, for every building, you will define concrete measures with concrete financial instruments, informations, and step-by-step renovation procedure, how to renovate the building to decarbonize that building until 2030. And this renovation could be part of energy certificate, and so on. So this is also a new measure which will be important and will help all the stakeholders to renovate and to see in which stage you are to how to come to the zero emission building. As I mentioned, so this renovation passport, it should be also issued by qualified expert. To say something more about renovation passport, what needs to be included all on. So also they will need to be mentioned about minimum energy efficiency requirements for the building, what is at the moment very important. On the other hand, what is going on with RES, how percentage is RES on the building. And as I mentioned, really important thing where all the stakeholders or the other households can get much more information and technical advice, and of course financial subsidies for the renovation. Smart readiness indicator, it was already today mentioned, really important, one of important measure. It will be start for beginning with non-residential building. Important. Also, we are reading some commission will also send us some extra act on that. But smart readiness indicator is one which will help to understand how building is prepared, how to communicate with other electric net from outside, how building has digital appliances, and how building can communicate with their owners. So this smart readiness indicator will be one of the visible measures to see with this digitalization of the non-emission decarbonized building stock. So here about methodology, this methodology will become also more defined and more important. So with that, I will stop with short presentation about EPBD, in which direction they're going, and I would like to apologize again because there is no my picture. Thank you.
Thank you very much, Eric. I think we should now upload the master presentation, please. I ask my colleagues to help with that.
Is going to be uploaded.
Okay. In the meantime, I don't see any question by the moment, so please I remind you to write in the chat any question. Okay, so now let's move to the Okay, now let's move to the third speaker, which is Mamak P. Carboni. She is a research fellow at Politecnico Torino, Department of Energy. She holds a PhD in energetics from Politecnico di Torino, and their research focuses on energy efficiency, climate resilience, building energy performance modeling, future-aware data creation, adaptation, and mitigation to climate change, and statistical data. As regards the title of the presentation, we are now moving to the quality assessment of the data from the EPC. The title is Techniques and Control Activities on the EPC Data to Evaluate the Reliability of Certificate Information. Mamak, you have the floor.
Hey, good morning, everyone. Thank you for Professor Corrada for the introducing me. So I will go through the presentation. Just the problem is that, sorry, I cannot take the control like that. The presenter has turned off the participant navigation.
You should be allowed to because you are a speaker.
Yeah, but for me, it's like that the presenter has turned off the participant navigation.
You need to click on take control, top button, the top side. Huh?
Okay.
Okay.
Now it seems to work.
Now it's fine. Sorry. So in this presentation, I'm going to briefly talk about data quality assessment. So as also in the first presentation, Alvaro was talking about the importance of controlling the quality of the data. So for exploiting the EPC, for implementing benchmarking and large-scale analysis, and checking the data quality is something necessary and inevitable. So deficiencies in current energy certificates and also potential improvements should be identified. So within the TIMEPAC project, 2 levels of assessments are performed. The first one was a qualitative assessment through the comparative analysis, which we have talked about in the first webinar. And the second one is quantitative assessment through rule and score attribution, which in this presentation we are going to talk about it. So first of all, the first step before the score attribution is to identifications of critical parameters and non-critical parameters. But what are critical and non-critical parameters? Let's say that the non-critical parameters are the EPC data, which the validity does not affect drastically the statistical analysis. And the critical ones are the ones that the validity of the data is considered fundamental for the statistical analysis. In this case, for the non-compliance rules for non-critical parameters, determine that the specific EPC data will be discarded, but for the critical parameters, if the rule is not met, the whole EPC data set will be discarded. So here, in the next slide, there is some example of the critical parameters. We can see like EPC ID code, building year, year of construction, thermally heated floor area, and so on. So the first step is identifying the critical parameters. Then the next step is to identifying the rules. So what are the rules that we are going to control? So there are 3 groups of rules that were considered, and these rules have been associated with both critical and non-critical parameters. So the first one is the data type check. So the simplest control, and it represents a set of rules which evaluate the data type. For example, if it's an integer, if it's a string value. For instance, the compactness ratio, as an example, is a decimal number and not a string number. The second one is the physical impossibility check. So which represent that the set of rules that evaluate the order of the magnitude of the EPC data by comparing them with the physical admissibility for the parameter. For example, the thermal energy need for space heating cannot be negative value. And the third one and the last one is the consistency check that represents a set of rules that determine the validity of a parameter compared to the another one. So, for instance, if energy surface for cooling is marked as it doesn't exist for a specific EPC data set, then the energy source for that space cooling should be rendered invalid or null. So in this slide, you can see that using the Excel sheet within the TIMEPAC, we have integrated all these rules to all the parameters. So type of the rules and also description of the rules. Some of them are just for data type checks, so you need just a data type checks. Some of them need data and the physical impossibility, and some of them, like for example, thermally heated gross volumes, you should have all the three groups of checks. So after that, the methodology used for it's the time for attributing the score to this data for critical and non-critical to evaluate it quantitatively. So the methodology used within TIMEPAC project for score attribution takes the inspiration from the extended project. First of all, the maximum score value is fixed to be equal to 1. And then considering that we have not the total number of the EPC data is n, and the number of critical parameters that have been identified are m, then we can say the threshold for non-critical parameters will be equal to 1 over total number minus the number of the critical parameters. And if the rule is not respected, and for the critical parameters, if the rule is not respected, the score will be the maximum, so will be the 1. But for sure, certainly there should be also a threshold for an invalidity score indicating the point at which an energy certificate, along with all include data, it's deemed rejected. And this is going to be controlled by the total score and by defining a acceptability threshold value, which is equal to this equation that you can see, and which is less than 1 always. So here you can see the application in the Excel. So for some EPC, in each row there exists the EPC data, the EPC data set. If a critical parameter is is unexpected due to the rules, so it gets the maximum score of 1, all the EPC database will be discarded. So, but if a non-critical parameter is attributed to a score, so it's the rule is not expected, just this data from the analysis will be discarded, not the whole database. But for sure, it is very important that for the reliable database, which doesn't have the critical parameters with a score of 1, we have to check the overall score and compare it to the threshold validity. Here there is an example of Piedmont region case that was calculated. So here the number of the total EPC numbers is 48. Then the critical numbers that had been identified are 10. So in this case, the score for unrespected rules for the non-critical parameters is equal to 0.026, and the threshold value is 0.63. So let's see how that would be implemented. So here in the Excel sheet, in each row we have the EPC data set, the first one, second one, to whatever we have. And in the columns we have the EPC data, so different data for each EPC, and then we have to calculate the data quality overall score, which is the sum of all the scores we have attributed to each of the data of in the EPC data, the critical ones and the non-critical ones. So if the sum, it will be over the threshold value, all the data set will be discarded for the future statistical analysis that we are going to do. So as you can see here in this example, just the ones that are 0, the other ones that are more than the threshold value in the example of the Piedmont region, which is 0.63, the other ones will be discarded. So just to close here, you can see the analysis that after all this score attributions to the Piedmont region case we have done. So the percentage of, we can see from these graphs that are the percentage of the invalid EPCs, we can see that the numbers are notable. So it's very, very important to do this quality check on the quantitative base. And we can see that the ones, the EPCs that have been rejected due to the wrong value of the thermal transmittance are in dark gray, and the invalid EPCs due to the other rules are in light gray. And we can see that the most energy performance certificates are rejected due to the null value or value above the physical limits of the thermal transmitters, in this case, in the case of Piedmont region. And we can say that approximately 30% are discarded because the overall score is higher than the acceptability threshold. And usually this happens in the data set that we have analyzed for the Piedmont region, because at least one of the critical parameters have an error. So that would be, the score would be 1 and it would be over the threshold. So for using energy performance certificate as a data source for implementing larger scale analysis like characterizing representative buildings or bottom-up energy model, which in the next presentations my colleagues are going to present, the quality assessment, even quantitative and qualitative, is crucial because you can see here that, for example, in some cases, for example, for educational building, for a specific construction period, it can be more than the 40%, which is a large number. Thank you for your attention, and if you have any question, I would be happy to answer.
Thank you very much, Mac. Before switching to the next presenter, just I would like to inform that I was informed that there is some technical issue in using the chat for making questions. It is due to setting constraints from Politecnico regarding the Microsoft Teams, but I think we can solve it in such a way. At the end, we will allow discussion. Participants will be allowed to raise their hand, and they will be allowed to speak and to make questions. So please wait until the end. We will open discussion session. So it's my pleasure now to present speaker number 4, which is Matteo Piro. Matteo Piro graduated in building engineering at Politecnico di Torino. He is currently a PhD student in the program of energetics at Politecnico. The research topic is focused on methodologies and tools for the enhancement of urban scale energy modeling. And the title of presentation is Data Clustering Techniques to Characterize Representative Buildings. Matteo, you have the floor.
Okay, hello everyone. Thanks for the introduction. So, as the title suggests, I'm gonna present you the techniques and the criteria to create the cluster in order to characterize the heterogeneity of the building stock in order to create the representative buildings. So this is the subsequent steps once you have assessed the quality of the data. So the presentation, the presentation before. So according to the scientific literature, the building stock energy model are usually classified in two different methodological approaches that are the top-down and bottom-up models. These two models are differentiated in function of the purpose of the simulation, the different level of granularity and correlation of data, and also the computational capacity requested to the computer to run the large-scale energy analysis. So the top-down models needs historical data series, and they study the relationship between three different fields that are usually the energy, economic, and technological sectors. These models are usually classified in function of the economic theory, so the microeconomic and the macroeconomic theory. On the other hand, the bottom-up models are the most used and common to create a building stock energy models, and they are usually classified in function of three different groups that are the engineering or physical-based model, the hybrid one, and the data-driven model. The main difference between the first and third approaches is that the physical-based model is aimed at solve the energy equation balance, and on the other hand, the data-driven models investigate, identify the mathematical relation that correlate the input to the output. So, and the hybrid one take into consideration the beneficial aspect of both the physical-based and data-driven models, so they can be part physical-based and part statistical or artificial intelligence-based. So the UBEM, that stands for Urban Building Energy Models, is composed, grouped three different subgroups that I have no time to go through, that are a pleasant user-based approach, archetype, and sample building-based approach. And also the data-driven models usually are classified in statistical and artificial intelligence. So the topic of today is the UBEM. So Urban Building Energy Model or modeling depend by the context, but they are crucial tool for public administrations, energy agencies, policymakers, and other key actors that are willing to analyze the energy and environmental performance of building stocks. So it's a useful tool to encourage also and to support energy renovation plan at municipal scale or regional scale. So one of the main issues of UBEM is the high level of uncertainty related to the input data. So the UBEM developer has to face this kind of uncertainty, especially exploiting and deriving the input data needed to run a UBEM model from local, regional, and national databases. So from this point of view, the easiest way to build a UBEM is considering an archetype-based approach. So the building archetypes or reference building or prototype buildings or building typology are buildings that embeds the most common technologies and technological aspect of a specific building stocks. And the building archetypes are composed by geometrical and non-geometrical parameters, such as the building envelope characteristic and the technical building system properties. And they can be classified in function if the geometrical data have been derived from the GIS, so it's the geometry of the building stock of the buildings is the same, is the real one, or if it's the geometry derived from the statistical sample. So the building archetype approach is a good trade-off to reduce the complexity of the model and to enhance to try to close to bridge the uncertainty of the input data. So archetyping, according to the scientific literature, is generally composed of two steps. So the first one is the clustering or segmentation or parameterization phase. That this is the topic of this presentation, and it's referred to the classification of similar buildings based on different criteria, such as the climatic zone, the building use category, the construction periods, and other indicators that we will mention. The second step is the characterization phase that corresponds to the definition of the representative relevant parameter that generalize the building stock performance. And this aspect can have we can say reflection on the type of data set of the building archetype. So the data can be described and reported from a deterministic or probabilistic point of view. So the main objectives of the clustering or segmentation phase are reported in this slide. So it's aimed at classify the heterogeneity of the building stock in several layers of categories. And of course, in order to group building with similar and comparable thermophysical properties and technical building systems characteristics. And the final aim is to determine the energy need, the different energy need associated to each cluster that we have defined. So in this slide, I reported the most used and common criteria to group similar building together. They usually, the criteria, the most used criteria are the climatic zone, because the building's energy need and performance are strongly linked to the external environment, so the climatic condition. The building use category, because it's influenced the functional requirements and also different building uses have to be complied with different building codes and regulation. And of course, the building use category define different indoor environmental quality requirements. So the occupant needs and expectation is different. So for example, the EAQ requirements from a swimming pool is different from a residential building. Another important criteria that is very important to be taken into account to group together the buildings and then to create the building archetypes is the construction period, because it is influenced by the architectural styles and construction techniques, and also it can influence the cultural and socioeconomic factors. And then we can add more criteria, such as the building size and shape. So, for example, according to the Italian legislation, the kindergarten and the university have the same building use category, but we can say that the size and the shape of the building is different. And other additional cluster to depend analysis can be considered. So, for example, socio-economic indicators or passive or active building performance. So, according to the criteria that I presented before, we in the TIMEPAC project we have defined a general methodology where the criteria considered are the climatic zone, the building use category, so residential and non-residential building, the construction period, the building size and shape for residential buildings, so single-family houses, multi-family houses, and apartment block. And then to go deep into the analysis, also the building fabric performances can be considered, so the thermal transmittance of opaque and transparent building envelope components, and also the space heating generator. So we have applied the general methodology to the EPC, to the Piedmont region EPC database, which is a region located in the north part of Italy. And here I reported the cluster that we have defined. So we consider the climatic zone E that represent the Po Valley area, and then the residential and non-residential building. For non-residential building, we have considered just offices and schools, and 8 construction period for each build use category defined, and this construction period have been derived from the European project so-called Tabula. And then for just residential building, we have clusterized considering single-family houses and building unit, EPC issued for building unit in apartment block or multi-family house. So the final part of my presentation is dedicated to justify from a quantitative point of view why it's really important to make this cluster, to clusterize the building. So in this graph, in this box plot, have been reported the thermal transmittance of walls divided for 8 construction periods, and these data have been derived from the EPC database and include merged together the data deriving from the climatic zone E and F, where the climatic zone F from the Italian legislation consider the Alpine and subalpine area, so the climate is colder. So the trend of the box plot is here presented, but if we subdivide the data according with their climatic zone, so the climatic zone E and F, the box plot are reported on the left of the slide. So on the right, we can see we have reported just the median thermal transmittance of walls, and we can see that the thermal transmittance decrease the colder is the climate, and it makes sense because in this way we reduce the transmission, and we reduce also the energy need of buildings if we consider just this element in the energy balance. So jumping to the conclusion, archetype-based model is the common and used approach for urban building energy model creation in order to determine and define the energy and environmental performance of building stocks, so such as blocks, districts, or entire cities. And the building archetype approach, as I said before, is a trade-off to reduce complexity and enhance the model's accuracy in the energy analysis. And the segmentation or clustering process plays a significant role in building archetype generation, because we have seen this on the previous slides, because it affects also the quality of the data. And the segmentation phase allows to consider the heterogeneity aspect of the building stocks. So it's everything from my side, and if there is any comment or question, I will ask at the end of the presentation.
Thank you, Matteo. Now let's move to the presentation number 5.
Okay.
Okay. The next presenter is Ilaria Ballarini. Ilaria Ballarini holds a master's degree in architecture and a PhD in technological innovation for the built environment from Politecnico di Torino. She is currently associate professor in building physics and energy systems at the Department of Energy of Politecnico. Her primary research focuses on building physics and building energy systems, with expertise in energy modeling of buildings and building stocks, methods for energy performance assessment, and cost optimization. So, Ilaria, you have the floor. The title of the presentation is Bottom-up Energy Model Using EPC Data as a Support Tool to Assess the Energy Performance of Building Stocks. And from this moment, you will be also the chair of the webinar. So I give you both the floors, as speaker and chair.
Thank you very much. So I'd like to start considering what you have heard until now. So the fact that an important aspect to model the building stock is to collect relevant data, is to process this data in order to increase the data quality, and to clusterize information according to some categories. So the fact is that now we have to move from data to a model of the building stock. In order to attain the objective of the EPBD directive that is now revised, we need to have effective renovation strategies scenarios for the building stock, because we have to create a reliable and accurate model at the end. So ideally, we should start from a real number of buildings and to assess them one by one in order to get the most accurate and detailed model. But this is, of course, an ideal way to proceed, because it's not possible to do this for many reasons. Because we have to consider that this way to proceed is time-consuming, because we have a lot of building to assess, also from data processing for our computer to process all this information. Another important issue is related to the lack of data, because we know that at the moment our existing buildings are very precious in terms of number of data, but these data are lacking, and we need them to do a reliable model. We need, of course, expert modelers to tackle with different issues related to the phenomenon behind the energy performance assessment. Again, we need tools. At the moment, we have a lot of tools for UBEMs, so for urban building energy modeling, but they are not so easily exploitable because they are usually, in some cases, difficult to be managed also by non-experts. And in addition, the model usually are not flexible, and otherwise we need flexible models to modify information, to share information also with other people. So given this premise, we have to move on and to anyhow to do a step back, considering what my colleague in the previous presentation said about the fact that a way to solve this problem is to clusterize the building stock into different categories and to adopt the so-called reference building approach. So to identify representative buildings in the stock that reflects the most common characteristics. These buildings could be real building or archetype building, and going in detail into the definition of building archetype, we could say that first of all it is characterized by statistical information. So the building archetype is a statistical composite of the features found within a category of buildings in the stock. This definition is taken from literature, as you can see in the slide. In addition, the archetype is not a real building, but it's virtual building, characterized by a set of properties detected in a building category. So two important keywords in this case that are the fact that building archetype is not real, but is virtual building, and that it reflects statistical information. So it has to be derived by carrying out statistical analysis on an amount of data. The archetype approach is well recognized in literature, as Dr. Piro said before, because it could be included into the so-called bottom-up engineering model for the assessment of building stock. Now, once we have clustered the building stock into archetypes, according to the rules that we have seen before, we are able to proceed in a way that starts from the single building and goes to the building stock. So we have here, for instance, an example of real buildings. Each real building inherits the characteristics of the building archetype of its category in terms of use, construction periods, building size, and of course the climatic zone, that is the most important element of the classification. Once we have the information of the building archetype, we have to assess the energy intensity of this building archetype, and then through the bottom-up approach, scale up the results. So multiplying the indicators by the numerical consistencies of real buildings, and then to get the building stock energy performance, both considering the baseline, so the current condition of the building stock, and analyzing the future scenarios, so considering some energy efficiency measures on the stock, and so to verify the energy saving potentials and the CO2 emission reductions, for instance. This is the overall procedure, but what is very important in this flowchart? Again, the importance to have data that are able to support our process. So not only data about, the characteristic of the stocks in terms of numerical assessment of real buildings and their characteristics, but most important are the data used to create the archetype. And so this is the approach that has been devised in TIMEPAC to develop urban building energy models, starting from the EPC's database as a source of data. This picture summarizes the work done that has been presented in the previous presentations in detail for each box in this slide. So we selected the data from the current EPC database. Then we proceeded clusterizing the data according to the categories of the buildings, categories and the construction periods. Then there was the analysis of the quality, so by removing inconsistencies, and then the statistical analysis. The statistical analysis is very important because starting from the sample of EPCs, of reliable EPCs, we were able to deriving the building archetypes. After that, the building archetypes are used to develop the bottom-up model in a subsequent phase. This is an overview of the EPC data selection, so the data that we used and we selected from the EPC, both the reduced XML and the extended one, to process the data and to get the information related to the archetypes. So the data you can see here are both general, related to the construction period, the use category of the building, and so on, but also more specific related to the thermophysical features of the envelope components and the features of the energy carrier and the efficiencies of the technical building systems, and also some energy indicators. Let's directly go to the results, because the central phases have been already presented. In the results, you can find the data, the schema that we have developed for each archetype. This is an example for Regione Piemonte in Italy, for a single family house of a specific construction period in the table on the right. And we have some parameters. And for these parameters, we have the results of the statistical analysis in terms of median value and interquartile ranges. On the left side, you can see the box plot that, of course, feed the table. And this box plot presents, for instance, different construction periods and for different types of components, like the opaque envelope components in the top part and the transparent in the bottom part. At the end of this application in TIMEPAC, we were able to develop more than 150 building archetypes, split by the different region or countries involved in the project. For each building archetype, you can see the overall table, so the table with the overall indicators presented for each building. The procedure to create the archetypes from the EPC has been reported in this document that is a deliverable produced within TIMEPAC, and you can access it is downloadable through this link. Finally, I wish to now to move directly to the bottom-up energy model. This is just an introduction, because the subsequent presentations will go in detail into this topic. And specifically in the project, we have developed a very easy tool on Excel that at the moment is able to assess energy performance and CO2 emissions, but it can be upgradable with the new functionalities like, for instance, the calculation of cost or other indicators. And the idea is to use the data from archetypes to scale up the results to the real buildings, so the numerical consistency of real buildings, and to get the calculation of the energy performance, the baseline of the building stock. In addition, it's possible to apply some energy renovation measures to the archetypes and to get the result of the building stock energy performance in the subsequent years. This model is not intended to replace the detailed human tools, but to exploit the archetypes in an effective way with a plain and transparent approach. So, concluding, I wish to highlight the fact that this building archetype approach could be an effective support for building stock benchmarking and for tracking the implementation of renovation measures. The precondition of the effectiveness of this approach is to have good data, so to have quite good data in terms of quality and amount of data, both to cluster the building stock and to create the building stock renovation plans. At the moment, the current situation of the EPC database is that there are some limitations because of the low quality information, but this limitation should be overcome thanks to the enhanced EPC that has been devised in the project, in TIMEPAC project. In addition, to be more effective in practice, all these procedures need training activities, reliable databases, also databases that are interconnected and interoperable in order to increase the effectiveness of these models and the accuracy. So thank you for your attention. And now I will go directly to the next session, section number 6, that will be presented by Susanne Geisler. Susanne is the owner and director of Serra Institute, that is an environment, and she's an environmental engineer with a background in law and a trained energy advisor entitled to issue energy performance certificates. Susanne Geisler's work focuses on promoting energy efficiency and sustainability in the built environment, with a particular emphasis on EPC-related practices and concepts. The title of presentation is Making Use of Renovation Roadmaps from the Building to the Building Stock, Exploiting the Renovation Passport Data. Susanne, the floor is yours.
Thank you very much, Ilaria. So what I would like to do is to link what has been said before with the forthcoming EPBD recast. So we will look at the National Building Renovation Plan and how it is linked with the renovation passport, as what Ilaria presented and her colleagues will provide useful information for the National Building Renovation Plans. And the renovation passport can improve data on existing buildings and renovation measures, and thus just contribute to improving the data situation. Why is all this important? Because we do not only talk about energy planning, but also about reporting. So it's important to see, are we achieving our targets? Are we on track? So when we look at the two relevant articles, first the article on the National Building Renovation Plan, then we see that it is a roadmap that should show or ensure a highly energy efficient and decarbonized national building stock. And of course, the basis is the transformation of existing buildings into zero emission buildings by 2050. We have a very detailed annex in that forthcoming recast, which actually is a template for the national building renovation plans, showing the indicators that are needed and all the data that should be provided. And when we look at the article on the renovation passport, then we see that here the provision is about a tailored renovation roadmap for the deep renovation of a specific building in a maximum number of steps to significantly improve the energy performance. And we also have that definition about deep renovation, saying that it means to transform a building into a nearly zero energy building in the first step and subsequently in a zero emission building. So it's about a roadmap for a specific building to transform it into a zero emission building. So these two articles are somehow, when you look at them, it's quite obvious that there are, let's say, some overlaps, or that the renovation passport scheme could contribute to an effective national building renovation plan. So when we look a little bit into more detail on that possible links, then we see that the National Building Renovation Plan, according to that annex, consists of, let's say, 4 parts. The first part is an overview on the national building stock. The second part is a roadmap for 2030, 40, and 50. Then the third part is an overview on policies and measures, how to achieve the targets. And the last part is on the investment needed to implement that plan. That's the specification of that National Building Renovation Plan. And when we now look at, let's say, the details, what does that actually mean and how could that link with the renovation passport scheme, then we see that there is one important element. This is the annual renovation rate. So we need to know how many buildings are renovated and in what depth are they renovated. We need the targets regarding the 2030, 40, 50 timeline. So what are the expected greenhouse gas emission reduction, for example. Then with regard to the policies and measures, when you look at that Annex 2, then you will see that there are many, let's say, requirements or requests that could be covered by a well-designed renovation passport scheme. And regarding the total investment needs, there could also come information from the renovation passports, because in the provisions on the renovation passports, we have that request that costs should be provided and also how financing could be done. So I just have to add that in this presentation, I will not go into details of the renovation passport scheme. This can be watched in webinar 2 and 3. And I will also build a little bit on what Eric said in his presentation. So it's just important to see it's a stepwise renovation roadmap for a specific building. So if we now have a little bit, let's have a little bit more detailed look at the potential of the renovation passport to improve the data on existing buildings and renovation measures. So that's the next part now. And in this regard, it's important that the forthcoming EPBD recast specifies that the renovation passport should be uploaded to the EPC database. So that's essential. And regarding the link between the EPC and the renovation passport, this link is also specified, namely that the recommendations in the EPC can be substituted by the renovation passport, including that renovation roadmap, how to renovate the building. So instead of quite general recommendations in the EPC, we can have that building specific renovation measures in the correct sequence with time steps. So in Austria, we have implemented such a procedure already based on the amending directive from 2018. And actually, it works exactly that way. If there is a renovation concept, it can substitute the recommendations in the EPC and as such becomes part of the EPC and is also uploaded in the EPC database. So let us just have a look at how such a renovation roadmap looks like. What kind of data can we expect? We have done several case studies in TIMEPAC, and what you see here is a summary of a renovation roadmap we did for an Austrian building. So what we have is packages of renovation measures at building level and at district level. And then we have, let's say, a part with remarks, explanations, and comments. So they refer to the correct sequence of the implementation of the measures, but they also give some information about things to consider, interlinkages. For example, if you do a renovation, if you do the insulation of the wall, you might have to consider fire safety, let's say, provisions, or regarding implementation of a PV system on a flat roof, you might have to consider the statics of the building. But this is nothing the EPC issue or the issue of the renovation roadmap will be able to do, because this is already renovation planning, and this is exactly let's say this is important to consider. The renovation roadmap is not a renovation plan. So it's about the correct sequence. It's about that interaction that need to be considered in the later renovation planning. And it is important that the renovation roadmap is uploaded to the EPC database, where it is then made accessible to the facility managers, who will then consider the roadmap in their maintenance and repair plan of the building. So this is the example we contributed to TIMEPAC, what we do in Austria. When I say there is a tool that gives information about the interlinkages, so what we used is a tool that is used for energy advisory services. It is included in an Austrian EPC software, and it has all the features that helps in let's say setting up such roadmaps. So the key aspect is that that roadmap is turned, or the key aspect is there is a link to the EPC database. So that's essential. And another key aspect is that this roadmap is turned into an EPC renovation plan when a defined package of measures is planned for implementation. So we have that form of EPC, which is then called EPC renovation plan. It is uploaded in the EPC database with the specific measures to be implemented. After completion of renovation measures, the EPC is updated, and also the renovation roadmap is updated. So the measures implemented are not included any longer. And all that is now stored in the EPC database, meaning that we know exactly which measures have been implemented, what is still planned, and how did the indicators change in terms of target achievements. This is actual information about the status of an existing building and the evolution of that building. And of course, that's also important for the evolution of the building stock. And as I said at the beginning, it's not only about planning, it's also about reporting. And this is emphasized, for example, by this recital of the forthcoming EPBD recast, which says that reporting should be done as part of the NECP, of the National Energy and Climate Plan, which needs a biannual reporting, and let's say the evolution of the building stock should be reported based on the national building renovation plans. So to conclude, actually my conclusions refer to the need for data availability and also data quality. The process of transposing and implementing the EPBD recast starts. And in this regard, we should use the opportunity to design the renovation passport scheme in a way to be effective at building level and to deliver useful information also for the national building renovation plans. Because if we have better information about existing buildings and renovation measures, it's easier to plan, evaluate, and adapt policies and measures. So that's all from my side. Thank you very much.
Thank you, Susan. Thank you very much. So now let's go to the last presentation. The last presentation is of Vincenzo Corrado. Vincenzo Corrado is a civil engineer and a full professor of building physics and building energy systems at Politecnico di Torino Department of Energy. He has experience in research and development in the fields of building physics, technical building systems, building energy performance modeling, energy audit and certification procedures, thermal comfort, indoor environmental quality, legislation and technical standards related to energy and environmental issues. The presentation is titled Energy Saving Assessment in Building Stock Deep Renovation Scenarios through EPC Data. Please, Vincenzo, the floor is yours.
Good morning, everybody. Thank you, Ilaria, for your kind presentation. So, to introduce the topic, I will start saying that an EPC database for sure is a core source of information on the building stock. The information from an EPC database can be exploited for a number of actions. And here you have a list, for example, to create the archetypes, which are representative of clusters within the building stock. This information can be also used to classify the main energy efficiency measures related to the different archetypes. Also to analyze the energy performance status of the building stock and to assess the energy saving scenarios for the building stock. And finally, to formulate building renovation plans both at national, regional, and local level. In this slide, you see a flowchart of the building stock energy model. And you see that starting from the information got from the EPC database, it is possible on one side to define some reference buildings, the archetypes, as it has been explained by previous speakers, but also to define standard refurbishment scenarios on each building archetype. Then, from this information, it is possible to set up an energy balance model of the building stock. To this purpose, it is also necessary to get more information from statistical databases, for example, coming from a national census. This model of building stock should be then compared with the building stock energy renovation model coming from applying the refurbishment scenarios to the reference buildings. At the end, this procedure allows to define short and long-term targets to be used in energy plans. I give you now some examples This first example comes from the EP database of the Piedmont region in Italy, and gives an overview, or better, a share of the residential building stock floor area, split by U value of walls on the left, U value of the windows, type of space heating system, and heat generator for space heating. So this overview gives you an idea of how the building stock is split into different levels of insulation quality, type of systems, and type of energy carrier used to feed the heating systems. Another important item is a standard definitions of the energy efficiency measures. EEM stands for energy efficiency measures related to the building. We can split them into EEMs related to the building envelope and to the technical building systems. In this slide, you see an example of possible measure to be considered for the building envelope, including the external thermal insulations of walls, including also a cavity wall thermal insulation, roof thermal insulation, floor thermal insulations, and on the other side, substitution of windows to get an increase of the energy performance, and installations of external solar shading devices. Moving to the technical building systems, also in this case, it is possible to classify and to define a certain number of measures. Typically, heating systems and also cooling systems can be split into subsystems. For example, the control, distribution, generation, emission subsystems are the subsystems typically used in the energy performance assessment according to international standards. And you see that, for example, if you look only at the generation subsystem, so we can define different measures: the installations of high efficiency chiller, the installations of generators for space heating, generators for domestic hot water, or combined generator for heating, cooling, domestic hot water. On the other side, you can see the possible installations of solar collectors, photovoltaic systems, the substitutions and improvement of the control subsystems, the installations of artificial lighting control subsystems, and of ventilation systems. Another example comes from some previous publications from myself and Ilaria. It gives an overview of energy refurbishment actions in Piedmont's dwellings, split by year and by type of intervention. And also in this case, this information comes from an analysis of the energy performance database. The next slide is another example giving the energy performance percentage decrease for different combinations of energy efficient measures for single family houses in Piedmont region, split by construction periods. You can see, for example, 8 different construction periods. The first one includes buildings built before 1900, and the different bars refer to the energy performance decrease for the different measures. For example, you see the light blue color means the decrease of energy performance related to transparent building envelope renovation. It is very small, more or less 10% of decrease, while on the other side, the green bar gives the effect of both opaque, transparent building envelope and space heating system renovation. And you can see that the reduction of the energy performance is between 60% and 40%. Moving to the activity performed in the TIMEPAC project, an energy performance tool has been developed to analyze building stocks. This tool allows to perform the calculation for specifically for residential building stocks, considering different building size and shapes, namely a single family house, building units in apartment blocks or multifamily houses and apartment blocks being considered. It is possible to obtain the building stock energy intensity through standard energy performance indicators derived from the energy performance certificates. You see the EPH and D represents the thermal energy need for heating, while EPH and REN and EPGL and REN represents the non-renewable primary energy for heating, and the GL represents the overall primary energy use, considering all the energy, all the energy services in the building. It is also possible to perform a simplified calculations for greenhouse gas emission of the building stock through the input of two energy carrier types for energy performance indicators. I'd like to present just an example. 3 renovation scenarios have been implemented in the TIMEPAC project. And to achieve long-term targets, it was assumed to get the same energy saving year by year up to the reachment of a national long-term target. And you can see how it is possible year by year to reduce the yearly energy saving up to the achievement of the national long-term target in a certain number of years. To conclude, we can state that long-term renovation strategies based on archetype-based building stock energy model derived from EPC data hold significant potential. This is especially true if we take into consideration the ambitious decarbonisation goals of the European Union. This activity for sure can engage multiple stakeholders, including public administrators, urban planners, local and national energy authorities that are the main stakeholders that can be interested in such a kind of activity. Of course, we have to pay attention to some aspects. The success of this approach is linked to some specific issues to be solved. First of all, it is necessary to have reliable and up-to-date data available. And it has to do with the quality checking of EPC, which is really an important issue far to be solved so far. Then the use of reliable energy assessment models, and this topic is strictly linked to the update of the international standards and to the customization of these standards for national applications. A third element to be considered is the adoption of standard procedures for collecting data on buildings and energy retrofit interventions. In my slides, I gave you some examples of standard approach to collect data and to collect and define and classify the retrofit interventions. And last but not least, it is really necessary to have reliable and up-to-date information on the evolution of costs, because at the end, the feasibility of any possible renovation scenarios is strictly linked to the cost effectiveness of the interventions, according to what is clearly stated also in the EPBD. It is my first slide, and I thank you for your attention.
Thank you, Vincenzo. So now we are very close to the end, but I would like to ask if there are some questions. Just a couple of questions we can answer, and then if there are more, so I mean, each speaker could answer via email. But please, the chat is not is disabled, unfortunately. So I can ask to raise your hand for question.
Yeah, only one question, I think, to you, Ilaria.
Yeah.
Or to one of your colleagues. Yeah, I want to ask, how do you summarize the information of EPC into an archetype of the building. I was thinking about you know, the apartments. Maybe there are some with I don't know, that have already been a renovation, and other that maybe still have an old configuration. And how can you describe the archetype of the building from many APC of all the units within that building? Thank you.
The sound was not so good, so I lost the last few words. The last few.
I try again. Sorry, just a second. Better now?
Yeah.
Yeah. Okay. Yeah. The question is about archetypes and the description of the archetypes, starting from the APC that are referred to the unit, and
to the unit.
Yeah, to the
apartment. You mean? Okay.
Yes. 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 How can, I don't know, if a building have I don't know 10 units, 10 apartments. How can you how can you describe?
Clear.
Yeah, have you understood?
Yeah. Well, now, thank you for your question. Yeah, of course, the archetype in this case, because it is created from EPC data, we considered the building, the archetype building for single-family houses, while for multi-family houses, so apartment block, we created an archetype of a building unit. Of course, this is not so interesting from a geometrical point of view, because of course the best way is to have an overall building as an archetype, not a unit as an archetype. But what is important is above all the information about the thermophysical properties of the envelope, the type of technical building system, the type of energy carrier that is used in the building or in the apartment. So so this is the point. So except the geometrical information, the archetype could be also created starting from the unit, the building apartment, if we focus well on these characteristics, on these features.
Okay, and in case you have like a mix of I don't know, a block of apartments built, you know, in that period, and into this building you have many different archetypes of units. Doesn't matter, or
No. We have not more archetypes in the same building. The archetypes is only an average. An average apartment.
An average, okay.
Yeah, of that period in that for that use category and so on.
Okay. Thank you.
You're welcome. Other question? The following.
Hi. Hello.
Hello.
Can you hear me?
Yes. Well.
Okay. Sorry, I'm on the phone, so that's why I'm asking if you can hear me well. I have a question regarding the definition of the most relevant variables, you might say, when making the quality or the data quality check on the databases. I recall the presentation where he made 1 over n minus m, and if it was possible to have an overview or an idea how can you define the m variables, the most relevant variables that have an impact on the overall energy assessment of a building.
Okay, thank you for your question. I give the floor to the speaker Mamak
Yes, thank you very
Turcaboni.
much. Yes, thank you very much for your question. It's like that. Before the M, which is the number of the critical parameters, they have identified as there was a definition between the critical and non-critical parameters. So critical parameters are the parameters that if they have a major influence on the final outcomes of the EPC data, like the thermal transmittance or the gross volume, heated gross volume, or the heated floor area, and the other things. So there are two different definitions. The ones that are drastically affect the outputs that exist in the climate, in the EPC data, and the other ones that do not have drastic effects. So the critical ones are the ones that have drastic effects.
And you,
I hope I answer.
And that drastic effect or that drastic impact is regarding the well, your experience when looking at that data, or by some kind of algorithm that might identify the ones that are more relevant in the assessment.
Yeah, for sure. It's more or less it's our expertise and our experience, and also using from the literature, other things, the simulations that we have done. More, I mean, it's a mix of our expertise, our experience, the literature, and other things. So just to start this score attributions, we have to identify these parameters, and because it's not possible to score all the parameters in the same level.
Yes.
So to say all of them are critical or all of them are not critical. So this categorization is important, and this application for sure is based on our expertise, our experience, and also the literature review.
Okay, thank you so much. Thank you.
Thank you for your question.
Thank you all. Okay, I don't see any question more in the chat. Or I mean, no hands that are raised. So okay, so the final remarks that I kindly remind you our last webinar, the 6th one, that is titled Operational Optimization of Building Energy Performance Based on Activities During EPC Generation. It will be on Friday this week, 22nd of March at 10. About this webinar of today, we ask your impression. Please take time to do this questionnaire. You can access this questionnaire through the QR code here, but you will receive also it by email. So thank you again for having participated in this webinar, and enjoy the TIMEPAC Academy.